Okay, so today, or day three, I should be, because we're going to be in day three for a long time. This is going to be the hardest part of factoring. It's going to be the factor by grouping because there's so many different ways that grouping can happen, and it's about recognizing which way is being presented to you, which might not always be very obvious. So what I'm going to do first, even though it might not make so much sense right now, I'm sort of going to lay out the I think it's 4 or 5 different ways to factor by grouping. And I'll tell you how to almost recognize it, and then we'll practice problems with it. So the first way we're going to factor by grouping, I'm going to split it into different categories, is going to be factor by grouping. And the first way we're going to discuss is if the polynomial I give you or the expression that I tell you to factor has 4 terms in it. And what distinguishes like a monomial from a binomial? What creates a term? What has to be there to create multiple terms? Enged? Addition or subtraction, you got it. So if we have 4 terms, our options here are going to be a 2x2 GCF, is one option. And I'll show you what that could look like. So if I have a 6x minus 6y plus 5cx minus 5cy. 2x2 GCF. Okay, so this is what I call a 2x2 GCF. What that means is I have my 4 terms. We'll check this. 1, 2, 3, 4. And what I mean when I say a 2x2, it means I group 2 terms together and then I group a different 2 terms together. So 2x2, group 2 sets of terms together. Now, our goal when grouping is that when I group things together, I have to be able to pull out a GCF. But the thing with this is not only do I have to pull out a GCF, I have to be able to pull out a GCF that leaves whatever's left in the parentheses the same in both groupings. And I'll show you what I mean by that. So if I go ahead and I group the 6x and the 6y, and I group the 5cx and the negative 5cy. In my first grouping, can't I pull out a GCF of 6? So I'm going to go ahead. I'm going to pull out that GCF of 6. In the second grouping, I can pull out a GCF, not just a 5, but a 5c. So I'm going to go ahead and do that. I'm going to pull out a 5c, and I'm left with x minus y. This is essential. When you choose your groupings, once you pull out the GCF, what's left in the parentheses has to be the same in both groupings. If it's not the same in both groupings, this isn't going to work. So the 2x2 GCF grouping means I group 2 terms together, I group a different 2 terms together, I pull out a GCF. What's left over has to be the same in both. The reason for that is if I'm looking at this as a binomial, where this is my first term, plus sign, this is my second term, I can pull out another GCF here. What's the other GCF I can pull out? Charlie? That's y. X minus Y. Some people might be thinking, why? Why are you allowed to pull out an X minus Y? Well, think about it. Let's say I use substitution. Let's say I let X minus Y be A. Wouldn't this be a 6A plus 5CA? Wouldn't I be able to pull out an A in that? Because it's multiplication between either side of the parenthesis. That's why I can still, either side of the plus sign. That's why I can still pull out a GCF, because it's multiplication between the 6 and the quantity of X minus Y, and it's multiplication between the 5C and the quantity of X minus Y. So I can absolutely pull out that GCF of X minus Y. So then when we pull out that GCF of X minus Y, I'm left with 6 plus 5C. And this is my factored form. I cannot factor any further. Okay, so this was still original 4 terms. So that was a 2 by 2 GCF. There's more. Our next option will be a 3 by 1 GCF. So if a 2 by 2 GCF means I grouped 2 terms together and then I grouped a different 2 terms together, what do you think a 3 by 1 GCF is going to mean? Violet? You got it. Group 3 terms together and leave 1 out. Let me give you an example here. Now, in the 3 by 1 GCF, it's exactly what Violet said. We're going to group 3 terms together. We're going to leave 1 term out. The thing is, the 3 terms you group together, it has to be a perfect square trinomial. What do I mean when I say a perfect square trinomial? What I mean is that when I factor it, it has to be some quantity squared. That's what a perfect square trinomial is. So when I choose my 3 terms to group together, I want it to be a perfect square trinomial. Then what's left out, that last term that's left out, it has to be a negative. Right? So again, for a 3 by 1, we want to group together a perfect square trinomial, and whatever term is not grouped, it has to be a negative. So I'm going to go ahead and I'm going to group my first 3 terms together. And now what I'm going to do is I'm going to factor this. X squared plus 4x plus 4, do we agree that's x plus 2 quantity squared if I were to factor it? And then we're left with a minus 9c squared. What have I just created here? Charlie?
Difference of squares.
You got it. We are creating a dots. Always. Every time with the 3 by 1. Now that I've just created a dots, now I can factor this. So this becomes an x plus 2 plus 3c and an x plus 2 minus 3c. Okay, so we did a 2 by 2 grouping, we did a 3 by 1 grouping. The last one is going for 4 terms is going to be a 1 by 3. Oh, I wrote 1 by 3 GCF up here. It's not GCF, it's 3 by 1 grouping. Sorry. So it's a 3 by 1 grouping. And this 1 by 3 is also a grouping. Okay, so an example of this would be okay, so in the 1 by 3 grouping means it's very similar to the 3 by 1. We group 3 terms together, we leave 1 out. The thing here is the 3 terms I'm going to group together. I think it's pretty clear, right? The y squared minus 10y plus 25. That's something we can factor. We hope that it's a perfect square trinomial. But when we group it together, this is a negative y squared. I have to include that there. Can I factor something when the leading coefficient is negative? No, but that was a negative y squared. So what I'm going to do now is I have to pull out a GCF of -1 to make that y squared positive. So this is going to be x squared minus the quantity of y squared plus 10y minus 25. This ends up becoming a perfect square trinomial. So when we factor this, we're going to have x squared minus y minus 5 quantity squared. So once again, what have we created? A dot. We've once again created a dot. Charlie, what's wrong?
Oh yeah, I don't think like it should be minus stuff, right?
I had to pull out a GCF of. Oh, sorry, my perfect. This should have been the negative. Sorry. So then this should have been positive. This should have been negative. I wrote my original problem wrong for what I wanted. Thank you, Charlie. So then this would have been positive and this would have been negative. That should work now, right?
Yeah.
There we go. That looks like a T, not a plus sign. Fix it. Okay, now are we good? Yeah, I think so.
Why would they switch?
Well, I wrote the problem originally wrong. But then, so this should have been right here, my original problem, negative y squared plus 10y minus 25. And then you can't factor if the leading coefficient is negative. So we had to pull out a -1. And then when we did that, we changed all the signs. Okay, so now what we've just created is a dot. So same thing here, we're creating a dot. And now we factor. So we're going to have an x plus y minus 5 and an x minus. Is it important that I keep the y minus 5 in parentheses? Yeah, because I'm going to have to distribute that negative. So it's going to be an x plus y minus 5 and an x minus y plus 5 factored. Yes, yes. Yes. Oh, what happened? I don't know. I don't know how this happened. There we go. Lily? Sometimes you might even have to change the order of the expression to even figure out what to group together. So the difference is usually the 1 by 3 versus 3 by 1. They're essentially the same thing. Is that the perfect square trinomial is put last because you have to pull out that negative. That's really usually what it is when you have to pull out the negative to be able to factor that. But they're essentially the same thing, same idea. So I spoke of 4 terms. I'm going to skip 5 terms for a second, and I'm going to go to 6 terms, but then we'll come back to 5 terms. So let's go to 6 terms. 6 terms is where it's a little bit ugly. Trying to find the right word for it. So for 6 terms, one option is going to be a 3 by 3 dots. And an example of this would be so we count our terms 1, 2, 3, 4, 5, 6. We have 6 terms. So when we have 6 terms, one option for factoring is a 3 by 3 dots, meaning I group 3 terms together and then I group a different 3 terms together. But when I decide what I want to group together, you want it to be perfect square trinomials, meaning when I factor it, it's going to be some quantity squared. So here I'm going to look and I'm going to see that, okay, well, I can group the first 3 terms together. And I can group the last 3 terms together, but I need there to be a minus between them. So I'm going to put a star here, must have a minus between them. And because I must have a minus between them, what should I pull out in the second grouping, Violet? A -1, you got it. So we're going to have a squared plus 8a plus 16 minus, and then we group again, x squared plus 4xy plus 4y squared. And then once I have my 3 by 3 groupings, then I want to factor them. And when I factor them, it has to end up being something to the quantity squared. And here, this ends up becoming a plus 4 quantity squared, which is great, minus. And the next one is going to be an x plus, anybody? 2y, good, x plus 2y quantity squared. So have I just created a dots? Absolutely. So now we factor our dots. So it's an a plus 4 plus x plus 2y. And then we're going to have an a plus 4 minus the quantity of x plus 2y. I'm going to distribute in that negative. So it's a plus 4 plus x plus 2y times a plus 4 minus x minus 2y. There's no like terms to combine, so I leave it just like that. Oh, and in the parentheses, it's addition, it's commutative. So you could write those parentheses in any order. It doesn't matter. So that was a 3 by 3 dots. All right, the other option for 6 terms I'll let everybody finish copying this because the next one you'll definitely want to focus in with me. Okay. We ready? All right. This will be the worst one. So this is going to be called the complex middle. Again, it's for 6 terms. So it's still under the category of 6 terms. All right, so an example of a complex middle. So I have 6 terms. So my only option for 6 terms is a complex middle or 3 by 3, a 3 by 3 dots. In this scenario, I know it's not going to be the 3 by 3 because I have a 3x squared. There's no way if I have a 3x squared that will ever factor into some quantity squared, right? There's nothing times itself that will give me a 3x squared. So I know this isn't going to be the 3 by 3 groupings. So this is a complex middle. When you have a complex middle, what you want to do first is group 3 terms together that you can factor. Any 3 terms that can be factored. So I can write out the steps. Group 3 terms that can be factored. So I'm going to go ahead and I'm going to group these first 3 terms. And then I'm going to go ahead and I'm going to factor the first 3 terms. So this becomes a 3x and an x. And then we're going to have a negative y and a positive 2y. So just to show you that I factored this correctly, I'm going to check the middle. 3x times a negative y is a negative 3xy. And then 2y times x is a positive 2xy. Doesn't that give us a negative xy? So I know I factored this correctly. So I'm going to use different colors here. That's negative 7x minus 8y. I'm just bringing the rest down. And then minus 6. Everybody okay with what I've done so far? All I did was group 3 terms together and then I factored. Now what you want to do is you want to look at this and we're going to actually factor again. But you know, normally when we factor, we have something that looks like, you don't have to write this down, but ax squared plus bx plus c. Ax squared is my first, bx is the second, c is the third. So we're going to look at this where this is my first term. This is the second term. And this is the third term. Now, when we factor, usually what we do is we set up a double set of parentheses. So let's go through it. So we have our first term, our second term, our third term. So I'm going to set up a double set of parentheses. And in the beginning of each parenthesis, isn't it usually factors of a? Like what multiplies to a, right? Well, I've already taken, this was my first term, I already broke it down into factors. So in the beginning of each parenthesis is each one of these factors. So the first parenthesis will have the 3x plus 2y. The second parenthesis will have an x minus y. That's going to be the first part of each parenthesis. So we're going to have a 3x plus 2y, and then we're going to have an x minus y. Now, when we factor, the end part of this, right, the end part of the parentheses are factors of the last term. But then we always have to check to make sure the middle adds correctly, right? That's what we do. So I need factors of negative 6 that will go here. But when I check it, I need to make sure when I check it adds to negative 7x minus 8y. So how are we going to do this? This is a guess and check. We're going to have factors of negative 6. We could have 6 and 1, 3 and 2. And we know one needs to be positive, one needs to be negative. We're not really sure, right? Which one's positive, which one's negative. So do you guys want to start with 6 and 1 or do we want to start with 3 and 2? Start with 3 and 2, sure. I'm going to purposely put it in the wrong area. So I'm going to put a 3 here and a 2 here just to show you. So this is wrong. But now when we check this, remember, this is my first term. So this whole thing, the outers get multiplied together, right, to check. So 3x plus 2y times 2 gives us a 4x. Oh, sorry, not a 4x, a 6x plus 4y, right? I distributed in that too. And then the inners get multiplied together. So I'm going to multiply these two. And 3 times x minus y gives us a positive 3x and a negative 3y. Now, we need to make sure that this adds to negative 7x minus 8y. So we check. Well, I guess the signs are a little bit off because we know one will be negative, one will be positive. But I'm going to ask myself, forget about the signs right now. Will 6x and 3x, any combination of positive and negative, ever get us a negative 7x? Never. And 4y and 3y, no matter what the combination is, positive and negative, will never get us to a negative 8y. Do we agree? So let's forget that now. It doesn't mean that 2 and 3 won't work. Now I have to try it in the other direction. I have to put the 2 here. So I'm just switching them, and the 3 here. And I guess I'll leave off the sign so you don't get confused. So now we're going to have 3x plus 2y times 3. That's going to give us a 9x and a 6y. And then we're going to have 2 times x minus y, which will give us a 2x. And I'm going to say a 2y. I didn't put any signs because we still have to figure out the signs. But is there a combination of 9x and 2x that could give us a negative 7x? Yeah. Is there a combination of 6y and 2y that could get us a negative 8y? Yes. So now we have to figure out which one's going to be positive, which one's going to be negative. So let's see. Well, do we want the 9x to be positive or negative? We want it to be negative because we need to add to negative 7x, right? So how did I get the 9x? This times this, so this has to be negative, which means 3x plus 2y times a negative 3 will give us a negative 6x, negative 9x, and a negative 6y. Do we agree? And that means the 2 has to be positive, which will give us a positive 2x and a negative 2y. We check one more time. Negative 9x and a positive 2x gives us that negative 7x. A negative 6y and a negative 2y gives us the negative 8y. We have our winners. It's a lot, I know. So our factored form is going to be 3x plus 2y plus 2 times x minus y minus 3. All right, the last type of grouping is 5 terms. Anybody still copying this? Okay, 5 terms. So for 5 terms, it's going to be a complex middle, and then I'm going to put sort of. Sort of like a complex middle, just a little bit. So an example of this would be 2x squared minus xy minus y squared plus 6y minus 8. So we're going to treat it like a complex middle where we want to group 3 terms together that can be factored. Any 3 terms that we can factor. So I'm going to go ahead and I'm going to group the first 3 terms together. And then I'm going to factor it. When I come to factor this, I'm going to get a 2x plus y, and then I will get an x minus y. Then we're left with plus 6y minus 8. So the reason I'm saying this is a complex middle sort of is we're following the same exact process of a complex middle. So this is going to be my first term. What had happened to the second term? It's just what? It's just a y, which means what happens to the x? It must have what? It must have canceled, exactly. So this is why it's a sort of, okay? So it's not so much of a complex middle. The x has canceled. And then we have our third term. So we have our first term, our second term, our third term. Okay, so now when it comes to factoring, I'm going to set up my double set of parentheses. And what's going to go in the front or the beginning of each parenthesis? Violet? You got it. So the factors of our first term are going to go in the beginning of each parenthesis. So we're going to have a 2x plus y and an x minus y. Now in the second part of the parenthesis, we're going to have factors of 8. Our options are 8 and 1 or 4 and 2. Where do you want to start? 4 and 2. Okay, where do you want to put the 4, in the first or the second? The second. Let's try it. So we'll do a 4 and a 2. So now what we want to do, let me put this in green actually, so you know where it's coming from. You said put the 4 here and the 2 here. Is that what you said? I think. Isn't that what you guys said? The 4 and the 2? Okay. So now let's go ahead and check this. So we're going to have a 2xy times 4. Remember, you multiply the outers, you multiply the inners to check the middle. So 2xy times 4 gives us 8x and 4y. And then we check the inners. 2 times x is a 2x. 2 times y is a 2y. I didn't put any signs. So now, is there a combination? Remember, what has to happen to the x? They have to cancel. Is there a combination of 8x and 2x that will cancel? No. So what does that tell you? This isn't right. Does that mean 4 and 2 are necessarily wrong? No, we have to switch and see what happens. So now let's switch and put the 4 here. And the 2 here and check again. All right, 2xy times 2 will give us 2xy times 2 will give us a 4x and a 2y. 4 times x minus y gives us a 4x and a 4y. Is there a combination of 4x and 4x that can cancel? Absolutely. And is there a combination of 2y and 4y that will give us a positive 6y?
Yeah.
Absolutely. So now we have to think of the signs. So we need, well, you tell me, where do you think the positive should go? And then that would be negative. Let's check it out. 2xy times this should be a negative 2. Sorry, let's include that. 2xy times a negative 2 is going to give us a negative 4 and a negative 2y. And then a positive 4 times x is a positive 4x. Positive 4 times a negative 2 is a negative 4y. Does that work out? No, the x's cancels, but what happens with the y's? They're negative. I need it to be positive. So what do? Change the signs. So this is going to be negative and this will be positive. We'll check it one more time just to make sure. 2xy times a positive 2 is a 4x and a 2y. Negative 4 times x is a negative 4x. Negative 4 times a negative y is a positive 4y. Does this now work out? Yes. So we end up with 2x plus y minus 4 and x minus y plus 2. All right, so I think I've made your brains hurt enough. We're going to stop today. Next class, we just practice. Next class, we just practice all of this.